Alright, hello everyone, this is Mr. Crozier. I'm going to go over your practice quiz for tomorrow. So, question number 1, we have a statement that says, if a shape has 4 sides, then it's a square. Well, that's obviously false, because it could be a parallelogram. And then we do the converse, which means we just flip the order and we put the square part first and the side part last. If a shape is a square, then it has 4 sides. Well, that one has to be true. So false, true. If an animal is a German Shepherd, then it's a dog. Well, that's true. German Shepherd is a type of dog. And then we flip it. If an animal is a dog, then it's a German Shepherd. Well, that's false. Could be a bird. Next one. If an angle is 90 degrees, then it's a right angle. Well, that's true. And if I flip this one, if an angle is a right angle, then it's 90 degrees. That's also true. What can you assume here? T and C intersect at line A, AF. Well, AF's right down here, and that's not the intersection. The intersection is right down here, so that's a no. C, D, and B are coplanar. Yes, they're on the same plane. B, C, D is a right angle. No, there's no marking right there, so that's a no. A, B is in the plane T. Yes, you can assume that. And point B is in the plane. Yes, that's also in the plane. Addition property, where you add both to one side, to each side of the equation. Transitive property, A is B, A is C, so they're both equal to A, so they're both equal to each other. Division property, just as it says, we just divide both sides by a number. Alright, going on to our main proof. Make sure you know this proof, it will be on the test. We have 2 lines intersecting to form 4 angles, and that's given. And we're trying to prove that they are congruent. We're trying to prove that they're congruent. Well, we know they're congruent because of their vertical angles. However, we have to prove that now. Alright, angle 1 and angle 2 make 180 degrees. If we have a straight line, then we have 180 degrees. And 2 and 3 make 180 degrees. If we have a straight line, then we have 180 degrees. If you can't remember what to put over here, just always look for an if-then statement. That'll always work. So now they're both equal to 180, so they're equal to each other. That's called the transitive property. Also substitution. And again, if you can't remember the word transitive property, just write out saying they're both if they're both equal to 180, then they're both equal to each other. Alright, now we get to this point and we subtract. We subtract off this angle 2, and we're left with exactly what we want to prove, that angle 1 is congruent to angle 2. Alright, prove that angle 1 is acute. Well, this definitely looks like an acute angle, but we have to prove it. Well, we have to figure out what y is. So we have two intersecting lines with angles as shown, that's given. Angle 1 is congruent to angle 3. Well, that's a vertical angles property, which we just proved up here, so we can use it down here. And now what we do is we say, well, angle 1 is 5y, and angle 3 is 7y minus 34. That's just some substitution. Subtract this over here, add this over here. We have 34 is 2x. Divide by 2, x is 17. Now we're going to plug it in. Angle 1 is 5 times 17, which is 85. Did some substitution and some multiplication. You can always do 2 steps in 2 reasons in a step. Don't do more than 2 different things in one step, but 2 is fine. And angle 1 is acute. Why is it acute? Because if an angle, don't need to say angle 1, if an angle is less than 90 degrees, and it's less than 90 degrees, then it's acute. So these are the steps, these are the reasons. Remember, if you can't remember the words, just write down what you did. And always try and get an if-then statement if you can. Alright, going on number 8, really short one here. We multiply this in here. I had a lot of questions with how do you multiply 2/5 times 15. Well, you just make it over 1 35ths, which is 6. I distribute, simplify, And then what did I do here? I did some subtraction property. I subtracted this over here, and I subtracted that over here, and I have x is equal to negative 13. You don't have to use all the lines. Sudoku puzzle, what is it? It's deductive reasoning because we have rules. When you have rules, you have deduction. When you are making guesses, you have induction. There is no guessing allowed in a puzzle like this, so you must use deductive reasoning. You must follow rules. What's inductive reasoning? That's when you're making conclusions based on guesses, based on observations. Basically, you're making a guess. Kind of like the weather. And here's an example. It's been cloudy all day, therefore it is going to rain. Well, that may or may not be true, but there's no rules about the weather right now. It's just we're looking out, we're making observations, we're making our best guess. Inductive is kind of like your best guess. Deduction, rules, induction. Yes, and what we do in our proofs is deduction. This is deduction up here. Alright, and what can we prove here? What can we assume? T, J, and Q are collinear. T, J, and Q, yes, they're on the same line. Ly is in the plane, yes. L, J, Q is right angle. Well, it doesn't even look like it. No. Q, J, Y is an acute. It definitely looks like it, but we cannot make that assumption. Alright, the last one, we have a diagram that looks like this, and we're saying that BFC, this angle right here is obtuse. And I suggest you write on your diagrams, put a little angle mark there and put a question mark, write the word obtuse. I'm trying to figure out that. Well, I'm given these values, and then I can say that this angle plus this angle makes 180 degrees, right? Because if it's a straight line, then it's 180 degrees. Then I can do some substitution. Take what I know about these, write them out, is equal to 180, simplify it, subtract it over, divide, and I have 20. Take your 20 for x, plug it into this formula right here, plug it in, or this expression. 6 times 20 plus 10 is 130. I substituted, I simplified this, and now I can say it's obtuse. If an angle is greater than 90, it is obtuse. So this definitely looks like it's obtuse, and it definitely is obtuse once I run through the proof. Again, try, if you're stuck, look for these if-then statements. If you know the words, use the words. If you know the property name, use the property. If you don't know what it is, just write out a sentence. Alright, hope this helps. The practice test.